To do a quick review over completing the square, and I'm going to do problems 6 and 7 from the journal. I just want to give you guys a video so you can have something to refer back to in case you missed anything on today. All right, so looking at number 6, we have v squared plus 6v minus 59 equal to 0. Okay, so the first thing that you want to do is you want to make sure it's in the format of ax squared plus bx plus c equals 0, and it is. All right, so you want to go ahead and isolate the c value. The opposite of a negative 59 is a positive 59, so I'm going to add 59 to both sides. This is going to cancel out. I'm going to bring down my v squared, my positive 6v, and then I'm going to combine like terms on the right side. 0 plus 59 is going to give me 59. So now we're going to complete the square. And you complete the square by using the formula b divided by 2 squared. So you're going to identify the b. The b in this quadratic equation right now, or the b that is on this side, is going to be 6, okay? So we already identified that the b is equal to 6. The a is equal to 1, because technically there's a 1 here, and then the c is a negative 59. So we have 6 divided by 2 squared, which is 3 squared. And 3 squared is the same thing as 3 times 3, which is equal to 9. So now we're going to complete the square by adding 9 to both sides. Okay, we're going to bring everything down. So we have v squared plus 6v plus 9, and then we're going to combine like terms. 9 plus 9 is 8. Carry the 1. 5 plus 1 is going to be 6. So we have 68. All right. All right, so now that we have this perfect square on this side with this quadratic, in the past we created these two sets of parentheses, and we said v times v is going to give us the first term, which is v squared. Then we list the factors of c, which is 1, 9, 3, and 3, and ask ourselves which two terms or which two factors can we multiply to get 9 and add to get the b, which is 6. And it's going to be the 2 3s, and we added the 3 to both sides. Well, instead of you having to do that because we completed the square on the left side, all you have to do is create your parentheses. The variable that is part of this expression, you're going to use that as your first term, and then you're going to find half of the b. Half of 6 is 3, so you're going to add 3 and then square it. So you still get the same thing, okay? v plus 3 squared is the same thing as multiplying v plus 3 twice, okay? All right, so now we're going to make this equal to the right side, which is 68. Now remember, in order to get rid of this squared symbol, we're going to have to do the square root. So the inverse of squaring a number is the square root, okay? All right, so when we do the square root of a squared number, this is going to cancel out, and that's going to give us v plus 3 equals the square root of 68. All right, so now we're solving for the variable v. In order to do that, we got to isolate that variable and get it by itself. So when you put the square root of 68, you need to understand that the square root of 68 is positive or negative. You know, quadratics have two types of solutions. All right, so we have v plus 3 equals plus or minus the square root of 68. So again, whenever you write your right side, you want to make sure that once you figure everything out and you see that you're doing the square root of both sides, you're going to put plus or minus in front of that radical. Okay, so now we're going to go ahead and isolate this variable. Now that I have my plus or minus, you're going to subtract 3 from both sides. This 3 cannot be combined with the square root of 68. So what you're going to do is you're going to write that in front of that plus or minus. So this cancels out, and v is going to be equal to negative 3 plus or minus the square root of 68. So the two solutions that we're going to have for this problem is v equals negative 3 plus the square root of 68 and negative 3 minus the square root of 68. Now, the square root of 68, guys, can be simplified. So we do have to make sure that you guys know how to simplify this to the simplest form. All right, so I'm going to move over to this little space. So yes, this is the answer here. That is our answer. But the 68, this radical can be simplified. So we need to make sure that we do simplify that. All right, so to simplify the square root of 68, I'll just go ahead and block this off so you guys can see. I'm going to move this over just a little bit. Okay. So we have the square root of 68. So you can do the prime factorization of this, or you can go ahead and list those factors of 68. Right. The factors of 68 we know is 1 and 68, 2 and 34, 4 and 17. I think that's about it. So I'm just going to check this real quick. I'm going to divide it by 5, 7, 8. I'm just checking. 9, 10, 11, 12, 13, 14, 15, 16, and we know 17. All right, so the only factors of 68 is 1, 2, 4, 17, 34, and 68. So you got to ask yourself, of these factors, which one is the perfect square and which one is the largest one? In case you have more than one, it's going to be 4. That's the only perfect square that we have out of all of these factors. So we know that we're going to use 4 and 17. So the square root of 68, the square root of 68 is going to be the square root of 4 times the square root of 17. All right, so when I simplify this, the square root of the square root of 4 is 2. And then the square root of 17 can no longer be simplified. So the actual solution, instead of being -3 plus or minus the square root of 68, your answer for B is going to be -3 plus or minus 2 and the square root of 16. So you do, again, want to make sure that your answer is in the simplest form. So these are the two solutions. And we have -3 minus that. So again, make sure you have your solution in the simplest form. All right, and you can pause and stop this video. And I'm going to also record problem number 7 from the journal.